Am I still lagging? Okay, let me know if I'm there. From the next class, it will be all right. I had complained that will resolve by tomorrow. So see, in the previous classes, we had completed carbohydrates. We had completed carbohydrates, and we also came to know about the super trick to remember all the monosaccharide carbohydrates. Now I'm going to start the next part of biomolecule, that is amino acids. It's very easy, amino acids. Please write the topic amino acids. So see, first of all, what is amino acid? Basically, there is an amine group and an acid group, that is called amino acid. I will show you. Basically, this acid you see, this is basically carboxylic acid, and this group is basically amine. So together they are known as amino acids. First of all, I am going to define what is amino acids. Write with me. An organic compound which contains carboxyl group, that means carboxylic acid, and amine group, amine functional group, that is called amino acids. Is that clear to both of you? Please write it, then we will go for classification of amino acids. Very good. Thank you. So this chapter is very easy, but this chapter is about remembering. So please be focused, and generally students, let's say, but you can score good marks if you have some focus on this chapter. Everyone done with this? Awaz, we just started this topic, amino acids, an organic compound in which amine functional group NH2 and carboxyl, this is XY, carboxyl group is there. That is called amino acids. Okay, so are you done with this? going to change the slide. Now see classification of amino acids. So this is classification of amino acids. How we are going to classify it? So it's very easy. So basically, we just classified the first class classification of the on the basis of a relative position. So this is classification of amino acid. Relative position of amino group. Can everyone see the screen now? Awaz, can you
Yes, sir.
see the
Yes, sir.
So basically, we are doing classification of amino acid, and the first classification is basically on the position of relative on the relative position of amino group and carboxyl group. Just suppose if you have this carboxylic acid, it's very easy, and this carbon and another carbon less. With respect to this carboxylic acid, this carbon will be known as alpha carbon, this carbon will be known as beta carbon, this carbon will be known as delta carbon, and this carbon will be known as gamma carbon and delta. Is my voice breaking?
Yes, sir.
Was Hamza, Nafisa.
Sir.
So what I was saying is classification is on the basis of relative position of amino group and carboxyl group. And you know how we are going to classify it. Basically, if this is carboxylic acid, so with respect to this carbon, this will be alpha carbon, this carbon will be beta carbon, this carbon will be gamma carbon, and this carbon will be delta carbon. So how we are going to classify this amino acid? So it's very simple. If we have an amino acid like H2N, and here hydrogen is, and here it is also hydrogen, and this is COH. Now you know that this is carboxylic acid. So basically, this carbon is known as alpha carbon, and with alpha carbon, NH2 is connected. That means basically this is alpha amino acid. This is alpha amino acid, also known as its name is glycine. Its name is glycine. If NH2 is connected with beta carbon, that will be known as beta amino acid. If NH2 is connected with gamma carbon, that will be known as gamma amino acid. Is that clear to everyone? Nafisa?
Yes.
Okay, please write it and let me know. Then I will give more and more examples. Very
Done,
good,
sir.
Nafisa. Hamza and Thomas, are you ready?
Yes,
So
sir.
this was
Finished.
the first example of alpha amino acid. Thank you. Now see, if I'm going to write this NH2, that means H2N, CH2, CH2, COOH, that means COOH. Please name it whether it is alpha amino acid, beta amino acid, and gamma amino acid. You can do it on your own. The first one is alpha, beta, gamma. Which amino acid? You can easily tell me. Nafisa, can you tell me the first one is alpha, beta, gamma? Which amino acid? Very good. So the first one you can see this is alpha, this is beta. So H2N, NH2 amine is connected with beta. That means this is beta amino acid. Tell me the name of the second and third.
Second one is gamma.
Very good. And this is delta, right?
Yes, sir.
Because it's alpha, beta, gamma, and then delta. So NH2 is connected with delta. That's why it is gamma acid, delta acid. Wait. Can I change the slide?
Sir, 1 minute.
Okay, please write.
Done, sir.
Nafisa and Hamza, what about you? Nafisa? Okay. Now, can anyone tell me amine group, that is NH2, is an acid or base? Is it acid or base? Can anyone tell me?
Sir, acid.
Carboxylic acid. See, its name is carboxylic acid, so everyone knows that it is acid. And NH2 is base. Amine is base. Always remember that, Fawaz, because it has lone pair and it can donate. And electron donor is base, and electron acceptor is an acid. Lewis acid and base. If you remember from class 11, what is Lewis acid? Electron withdrawn group or electron gainer is, or electron acceptor is an acid, electron donor is a base. Is that clear? Nafisa, am I audible to you? the next classification is basically classification of amino acids on the basis of pH value. pH value. That means amino acid is neutral, acidic, or basic. Everyone knows that if pH is equal to 1, what does this mean? If pH is equal to 1 to 6, what does it mean? Acid or base?
Base.
Now, look at the question. 1 to 6 or 1 to 7, almost equal to 7, less than 7, that is basically acid, and pH greater than 7, that is base. So we can also write for acid pH less than 7. So pH less than 7 is an acid and pH greater than 7 is a base. Is that clear?
Yes, sir. Okay.
Now I already told you that amine is base and carboxylic acid is an acid. So how we are gonna classify it? It's very easy and simple. Number of NH2 group is equal to number of COOH group. Then it will be neutral, isn't it? If acid will be equal to base, then the compound is neutral or not. That means pH is equal to 7. Are you getting my point, Nafisa and Fawaz?
Yes, sir.
Yes, sir.
Now see, number of NH2 group, that means basic group. If base group are greater than number of COH group, what will be the nature of compound? Acidic or basic? Tell me. What is NH2? Base. And if base
Yes,
is
sir.
greater,
Basic.
it will be base. Very good. That means pH greater than 7. And again, if we have number of NH2 group, that means basically basic group lesser than number of COOH group, that means acidic group is greater.
Acidic.
So what does it
Acidic.
mean? The acidic and the pH will be lesser than 7.
Lesser than
Is
7.
that clear?
Yes,
Yes,
sir.
sir.
Please write it. Let me know when you are done with this.
Yes, sir. Finish.
Very good. Thank you. Fawaz, are you also done with this?
Yes, sir. Yes.
Okay. Now, type of amino acid. There are two types of amino acids. There are two types of amino acids. What it is? So basically, it is essential amino acid and non-essential amino acid. So basically, this is also the classification. Wait a minute. All are basically we can write classification of alpha amino acid on the basis of requirements. On the basis of requirements. So basically, the first one is essential amino acids. Essential amino acids. That means an acid which is absent in our diet. We have to, which is absent in our diet, or that is amino acid is known as essential amino acid. I'm going to define it. You get it. I'll explain again. Those alpha amino acids which cannot be synthesized in our body. Synthesized in our body. So basically, we have to take this from outside, like in diet and all. So those alpha amino acids which cannot be synthesized in our body must be taken. This must be taken or present in our diet. In our diet. If these are absent in our diet, these are absent in our diet for a long time, it may lead to deficiency of disease. It may deficiency disease. So basically, essential amino acids are those acids which is not present in our body, which cannot be synthesized in our body. So we must take it from outside, like we must take it in our diet. If we are not going to take it for a long time, there will be disease. That will be basically deficiency of that disease. We can take example in a mnemonic like VI. V for valine, I for iso, leucine. You have to remember the name because questions has been asked. Write 3 examples of essential amino acid, or it can be written as define an essential amino acid with example. And T is for phenylalanine. Phenylalanine. This is together. Another example I can write. We can go by the name PMT. PMT. P for basically P for same, basically phenylalanine. M is for methionine. And T is for tryptophan. All example of essential amino acids that you should remember.
Yes, sir. Finish.
Very good. Was
Sir, 1 second. Yes, sir, done.
very good. Now see, the next type of amino acid is basically non-essential amino acid. That means basically this amino acid can be synthesized in our body. So we don't need to take it from diet. Non-essential amino acid. What it is? Those alpha amino acids which can be synthesized in our body. So these are not required from outside. As for example, we can take glycine is non-essential. That means it will be synthesized in our body. Alanine is also. Cysteine is also non-essential amino acids. Please write.
सर ये अलामीन के बाद क्या लिखा है?
This is alanine and this is cysteine. CYSTEI. Let me know when you are done with this.
Yes, sir.
Thank you. Are you done with this?
Yes, sir, done.
Now gonna start the structure of alpha amino acids. Structure of alpha amino acids. So what is this? How we are gonna see see basically what is the structure of alpha amino acids? You know that this is H2N, and if I am asking you which type of amino acid is this? So you can easily say this is an alpha amino acids because NH2 is connected, because this NH2 is connected with alpha carbon. That's right, it is alpha amino acids. So basically, if you are going to replace this R with H, then you will get glycine. That means basically H. R is replaced by H, and there is NH2, and the same structure like this, C double bond O. Now you can easily see that this is replaced by, wait a minute, this is replaced by, R is replaced by H. R is what? R is basically alkyl group, and you can see this is also, this is, so this is basically our glycine, what it is, glycine. And if this R and this H will be replaced, like if I'm going to write C and this R is replaced by CH3 instead of H, this will be alanine, this will be alanine, C double bond O. Both are alpha amino acids, but the difference is that this is alanine and this is glycine. So please write it. And then there are some points that we need to take care. Let me know when you are finished with this.
Yes, sir. Finished.
Very good. What about you, Fawaz and Hamza?
Sir, done.
Now see, Fawaz, there are some points which is important to know. Right with me. Alpha amino acids are optically active, except glycine, which is not optically active. Next point is basically glycine is sweet in taste. Here you can see this GLY is sweet. This GLY means sweet. Now the next point we can write. Tyrosine is obtained from cheese. And you can see tyro means basically cheese. So these 2 points you need to remember.
Yes, sir. Finish.
Fawaz,
Yes, sir, done, sir.
very good. Now see, there is a term that is Zwitterion. And what is Zwitterion that we are going to talk about? The fourth point is basically, you know that this is alpha amino acid. You can easily recognize this is alpha amino acid. And you can see, as we know that hydrogen is very less electron negative than oxygen. So it will take electron from this hydrogen and it will be like this O minus and then C double bond O, then C, then here it was H and R. Now see, already we know that nitrogen has lone pair, and since hydrogen's electron taken by oxygen, so it will be in need of oxygen, so it will attack here and there will be another bond that is NH2. So this is basically dipolarian. We call it dipolarian.
Sir, is this like the mirror image of the first structure?
No, it's not mirror image. Can you see there is positive charge, negative charge? How can it be mirror image? It's called Zwitterion. And what is Zwitterion? Zwitterion is a dipolar ion in which positive and negative charge present on. Not single. This is
Yes, sir. Finish.
very good. What about you, Fawaz and Hamza?
Yes, sir, wait, sir.
Okay.
Done, sir.
Now see, we are going to start the next topic, that is protein. And there will be peptide linkage. So write the topic, that is protein. Here we can write peptide linkage or amide bond. What is this peptide linkage and amide bond? So it's very easy to understand. See the bond O and H. This is peptide linkage or amide bond. So basically the amide linkage or peptide bond, or we can write peptide linkage, amide linkage or peptide linkage. Join alpha amino acids, alpha amino acids in protein, that is basically called peptide linkage. So basically, when peptide linkage or amide linkage joins alpha amino acid in protein, so we will see how it will link each one, and there will be a bond that will be known as amide bond or peptide linkage. So please write it, and with the help of example, you can easily understand.
Sir, what's beside linkage?
This is peptide, and this is amide.
No, the one besides peptide linkage.
Okay, this is join. Are you talking about this?
Yes, sir.
Please let me know when you're done with this.
Yes, sir. Finish.
What about you, Fawaz? So now you can see with the help, very good, with the help of an example. There is glycine. You know that glycine, I can write NH2 as this. And there will be H and H. And there will be C double bond O, OH. What is this? This is basically our glycine. And if we are going to add another another amino acids, you can see there is H, there is C, and there will be C double bond OH. So there will be removal of water. How removal of water will take place? So this will be part of, wait a minute, a removal of water too. So you are going to remove this water and join this. So this is alanine, you can see, and the first one is glycine, and then we will get NH, and then H, C, H, then C double bond O. And the rest will be same. So this part basically is the linkage, and also known as, this part is also known as dipeptide. Dipeptide, and we write it, the first is gly, so we will take CLY, and the next alanine. So this compound is known as gly-alanine.
Done, sir.
Very good. Are you done with this, Nafisa? Nafisa, are you done with this? Hamza?
Yes, sir.
See, now we are going to talk about this polypeptide chain. So when we talk about polypeptide chain, so what it is basically, right with me. It is the chain of alpha amino acids in which alpha amino acids are attached by peptide bond, or we write peptide linkage, or we can write amide bond. So basically, C double bond, we are talking about this C double bond O and is right.
Done, sir.
Everyone done with this? Now we are going to classify protein. So here it is. Classification of protein on the basis of shape. So there are two types of proteins. One is fibrous protein and another is globular proteins. So I'm going to write this is globular proteins and this is fibrous protein. So I'm going to differentiate between these two, which is very important. So the first is they have merely a spherical structure. They have merely a spherical structure. And what about fibrous? They have linear thread structure. They have linear thread like a structure. Next point we can write they are soluble in water. They are soluble in What about fibrous? They are insoluble in water. Next point we can write. They have alpha helix structure. They have alpha helix structure. It is. Last point we can write about this. Who is the host now? I'm just Sekhani, you are the host. Can you make me host, please? Okay, thank you. So I was talking about, thank you. I was talking about example of globular protein in which insulin and albumin is globular protein. Keratin is fibrous protein which is present in hair, wool, cell, etc. And another example of this is myosin, which is present in our muscle. So these are two examples of fibrous protein and globular protein. Is right.
सर थोड़ा ऊपर जाइए इस
Will it be enough?
ठीक 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 है बस हाँ सही
Everyone done with this? Let me know when you're done with this.
Done, sir.
Very good. Nafisa, are you done with this? Okay, I'm going to change the slide. Now see, we are going to study about the structure of protein. Basically, what is the structure of protein? So the first is primary structure of protein. Primary structure of protein. So what is this? So I'm going to define it. It refers to polypeptide. To the polypeptide chain. In which amino acid are attached with each other.
Sir.
Yes.
नहीं sir कुछ.
Wait a minute. Learnivio is the most. So you can see it refers to the polypeptide by tight linkage. Tight linkage. Specific sequence. Like linearly, you can say specific. Means specifically linearly. As for example, like alanine, they are linearly friends. Alanine, it is with glycine and alanine. So you see like this. So this is an example of protein. So I'm going to show you the example also. I will write the structure also. First, you are going to write it.
Sir, what are the examples?
alanine, glycine. They are sequentially arranged.
Oh, okay, sir. Yeah. Okay.
Done, sir.
Very good. Everyone done with this?
Yes, sir.
Now, see, we are going to talk about the next. That is secondary structure of protein. I will show you the structure of protein. So I'm going to define it. Basically, it refers to the shape in which long polypeptide can exist. And basically, there are two types of secondary structure of protein. Secondary structure of protein. So it is basically alpha helix. I'll show you the structure also. And beta plated sheet structure. Then it will come about the tertiary and then quaternary. Let me know when you are done with this.
Done, sir.
Very good. Now we are going to talk about tertiary structure of protein. See what is tertiary structure of protein. It's very simple also. It refers to the further folding secondary structure of protein. Secondary structure of. So if you are going to further fold the secondary, you will get tertiary. Also, it is important to know that this tertiary will give you to this. I'm going to write tertiary the structure of protein. Gives two type of molecular subgroups. Gives two type of molecular shape. The first one is, you already heard about it, globular and fibrous. So we already know about globular. So this is globular further folding. Globular, what is it? What it is? Further folding of alpha helix. Further folding of alpha helix structure in the form of a sphere. In the form of a sphere. Then globular protein forms. Globular. So it's very easy to understand. What is alpha helix? Basically, secondary structure of protein has two types: alpha helix structure and beta plated structure. So in tertiary structure of protein, we have two shapes: globular and fibrous. So what is globular? So basically, when you are going to fold more, further folding of this alpha helix structure, then you will get globular protein. Please write it. Then we will talk about fibrous. Fibrous is basically further folding of beta plated sheet. Then you will get fibrous. Please let me know when you are done with this.
Done, sir.
Yes, sir.
Very good. Now we are going to talk about the another shape like fibrous. The second is fibrous. So further folding of beta plated sheet, that is fibrous. So I'm going to write further folding of beta plated sheet structure form of cylinder. Cylinder forms beta plated. Forms basically globular. Globular. Only the last structure of protein left, that is quaternary structure. We will talk about it right now. So quaternary structure. Please let me know when you are done. Let me know when you are done with this.
Done.
Very good. Now, what is this basically? Quaternary. Quaternary structure of this protein. So basically, it refers a spatial arrangement of subunits with respect to each other. With respect to each other. That is basically quaternary structure of protein. So if you want to see how this works, basically you can see. Now, I'm going to write the structure of primary. So this is basically primary is linearly arranged like this. You can see like glycine, 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 alanine, and all like this. So this is the structure of primary. It's very easy to understand. So basically, it is like this. This is our alpha helix. When we talk about beta shape, then it is basically, it is like this. When you talk about tertiary, so basically tertiary is like this. When you talk about this quaternary, I'll show you. Please write it. Please let me know when you're done with this. Then I'll show you quaternary.
Done.
Done, everyone? So basically, this is our the right hand side. In right hand side, you can see a picture that is quaternary, a spatial arrangement of the in our a spatial arrangement. This is called quaternary. Is that clear, everyone?
Sir,
Am I audible?
Huh?
Am I audible?
Huh, sir? Yes, sir.
Okay, again, I'm going to share it. So you can see in this picture, quaternary, primary, and this is our basically